Hello friends, today I am going to discuss statistics. So first, what is the statistics and where do we use statistics? So statistics is used in all kinds of science and arts and business applications. So it gives like a more accurate knowledge which helps us make a better decision. So we can focus on making a predictions and what will happen in the futures. It can also like a focus like a explaining how the different things are connected. So most of the time we see like the good statistical explanations are also useful for predictions. So let's before that we try to understand that there are some steps of the statistical methods. So first we need to collecting a data. Second step, describing and visualizing data, and third, making conclusions. So now it's the most important to keep all these kind steps, all three steps in mind, and you can get a more knowledge about this. So the data are available all over the world. So every second data is generating, like Google is generating the every second data, and Facebook is also, Netflix is also, Amazon is also, all are creating us data. So millions of the data has been generated, and all data is collecting through organizations. So a lot of data might be available, and knowing what to focus on it important, like weather forecastings, energy data. Okay, so statistics can be, how is statistics used? So statistics can be used to explain the things in the different way. So we can use it understand to make the conclusions about the group that you want to know more about. So the group is called like a population. Populations could maybe the different kinds of groups, like all the peoples in a country, all the businesses in industry, all the customers of a business, all peoples that play football. So who is older than others? So these are way to understand. Another, the gather the data about the populations and will give you a sample. So it is sometimes it is not possible to can analyze the whole data, so we need to the collector samples. Suppose just you are going to like a elections forecasting, so it is not possible to the you can go like the every people can talk with you, each people not able to talk with you. So in this type in this time, at this time you can like collect the samples and then we can go for castings. Okay, so this part is the whole like a populations method we can use like this, and we can get we can like the sample is used to make a conclusions about populations. Some important concepts in the statistics like predictions and explanations, populations and sample, parameters and sample statistics, and sampling methods, data types, measurements label like a data type times these data types, panel data types, right? Other you can say also like individual data, continuous data, these are the data. Measurement labels, descriptive statistics, random variables, univariate and multivariate statistics, probability calculations, probability distributions, statistical interference, parameter estimations, hypothesis testings, correlations, regressions analysis, and causal interferences. So statics and programming. So statistical analysis is typically done with the computer. So small amounts of the data can analyze reasonably well without computers. So historically, all data analysis was performed by mutually, and it was time consuming and prone to error. Nowadays the programming and software is typically use the data analysis, and we will try to discuss each and everything. So first we try to understand the populations. So populations is then all the peoples, like in India is called the populations. So all the members of the populations, and similarly the representative samples, the sample needs to be similar to the whole populations of India, but it should have the same characteristics as a populations. So if you only include a people name like the Rohan living in Mumbai, so who are like a 48 years old, the sample will not be the similar to the whole populations. So for a good samples you will need people from all over in India, the different ages, professions, and so on. So if the member of the samples have a similar characteristics like the age, professions, and etc., whole population of India, so we say that the sample representative of the population. A good representative samples is a crucial for statistical methods. Next, we will see here the describing a data, like the informations from the sample populations can be visualized with a graph or summarized by numbers. So we can see some key informations in a simpler way than just looking at a raw data. It can help us understanding how the data is distributed. So graph can visualize like a histogram, pie chart, bar graph, box plots. So some graphs have a close connections to a numerical summary statistics, and calculating those gives us to the basis of these graphs. For example, the box visualized show the quartiles of the data, and quartiles are the data into the 4 equal size parts, and quarters and quartiles one type of the summary statistics. Similarly, the summary statistics takes the large amount of information and the sum it up. Now the some key value, like the some important example: mean, median, mode, range, and interquartile range, quartiles and percentile, standard deviations and variations. Okay, and now the some stats making us some conclusions also, like stats interference. Because stats from the data in the samples is used to make the conclusions about the whole population. So this is the type of the statistical interference. Probability theory is used to calculate the certainty that those statistics also apply to population, and when using a sample there will always be the some uncertainty about what the data looks like for the population. Uncertainty is often expressed as confidence intervals, and confidence intervals and numerical way of showing how likely it is that the true value of this statistics is with the certain range of population. Next we will discuss like a hypothesis testing is the another way to the checking if the statement is the about the population is true, and more precisely it checks how likely it is that a hypothesis is true is a basis on a sample data. Like you can take some example like people in the uh, Indians, yeah, you can say the other country, Indians taller than the people in Nepal. So, do the people prefer like a Pepsi or Coke? And does the new medicines cure a disease? So, casual inter inference, you can say the casual inference is used to investigate if the something causes another things, like does rain makes plants grow, and if we think two things are the related, we can investigate to see if they correlate. Statistics can be used to find how strong this relation is, and stats like predictions. So statics like predictions, and you can see the some types of the statistical method focus on predicting the what will happen, and other type of statistical methods are focusing the explaining how things are connected. So predictions means some statics methods are not focused on explaining how things are connected, only the accuracy of predictions is important. Many statistical methods are successful at predicting without giving insight into how things are connected. Some types of machine learning lets computer do the hard work, but the way they predict is difficult to understand. These approaches can also be very valuable and vulnerable to the mistakes if the circumstances change, since how they work is less clear. So predictions about like a future events called a forecast. Not all predictions are all about the futures. Some predictions can be about the something else that is unknown, even if it's not the future. Explanations. Different statistical methods are different used for the explaining how things are connected. These statistical methods may not make a good predictions. These statistical methods often explain only a small parts of the whole situations. But if you only want to know how a few things are connected, the rest might not matter. If these methods accurately explain how all the relevant things are connected, they will also be a good at prediction. But managing to explain every detail is often challenging. Sometimes we are especially interested in figuring out if one thing causes another. This is called the causal inference. If we are looking at the complicated situations, many things are connected to the figure out what causes what. We need to understand every way these things are connected. Next, you can see here the some populations and the samples. So the populations means everything in a groups that we want to learn about, and samples means part of the populations. Let's see the what is the difference of. So populations means all of the peoples in India and 500 Mumbai peoples. All the customers of Netflix and 300 Netflix customers. It's a sample. And every car manufacturers and Tesla, Toyota, Maruti, these are the samples. So for the good statistical analysis, the sample needs to be as similar as possible to the population. So if they are similar enough, say that the sample is representative of the population. The sample is used to make conclusions about the whole population. If the sample is not similar and enough to the whole population, the conclusions could be useless. Next, we try to understand like stats parameters, and so the terms of the parameters and a simple statistics, it like a concept that are closely related in the statistics. So they directly connected to the concept of populations and the samples. So parameters, the number of the describe the something about the whole population. Sample statistics, the number that describe the something about the sample. The parameters are the key things we want to learn about. The parameters are usually unknown. Sample statistics gives us estimates for parameters. There will always the some uncertainty about how accurate estimates are. More certainty gives us more useful knowledge. Like the mean is a parameter, the simple statistics like a simple mean, and median, simple median, mode, simple mode, variance, simple variance, and standard deviations, simple standard deviations. So mean, median, mode are the different types of the average. So typical age of the people in the country, typical profit of the company, and typical range of the electric car. So the variance and standard deviations are the two types of value describing how spread out the values are. Single class like students in a school would usually be about the same age. The age of the students will have the low variance and standard deviations. The whole country will have a people all kinds of the different ages, so the variance and standard deviations age of the whole country would be bigger than the single school grade. Next, just study types like a statistical study can be the part of the process of the gathering of data. So there are different types of studies. Some are the better than other, and but they might be harder to do. So main type of statistics means like observations, and another is the experimental studies. And we are often like interested in knowing if the something it is a causes of the another things. Now experimental studies are generally better than observational studies for investigating things, but usually require more efforts. And observational study so is when observed and they gather the data without changing anything. Experimental study means any experimental study like a circumstances around the sample is changed. Usually we compare the two groups from a population, and these two groups are treated differently. One example can be a medical study to see if a new medical is effective. One group receives the medical and the other does not. So these are the experimental. And similarly the simple, you can different types of the simple methods. Random simples means where the average members of the populations has equal chances to the choose. The random simples is the best, and but it can be a difficult or impossible to make sure it is the completely random. So convenience sampling, like a convenience sampling, it is where the participants that are the easiest to reach and choose. So systematic samplings, like a systematic samples, is where the participants are choose by some regular systems. Like suppose the first 30 people in a queue, so every third on the list, and the first 10 in the last 10. Stratified sampling, like a sample where the population is split into the smaller group called the stratify. Stratify can be like a different age groups, professions. Another is the cluster sampling. Cluster samples where the population is split into a smaller groups called clusters, and the clusters are usually a natural like a different cities in the country, and clusters are chosen randomly for the samples. So all the members of the clusters can the participate in the samples. Members can be the randomly like from the clusters in the third steps. Now another just is the different types of the data, and main the two types of the qualitative like a categorical and quantitative like a numerical data. These are the main also, and the different subtypes of depending on their measurement level. Like a qualitative type of data informations about the something that can store into the different categories that can be described directly by numbers like a brand, nationality, professions. So with the categorical data we can calculate a statistics like a population. For example, the populations of Indian people in the world and the percentage of the people of prefer one brand to another. Similarly, we can take the like a quantitative data information about the something like a described by a numbers like a income, age, heights, and we can calculate like a average income in the country, range of height of players in the football team, and another just the measurement level. So different data types have a different measure levels. So measurement level are important for what types of statistics can be calculated and how the best present data. So measurement level. So the main types of the data is qualitative, categorical, quantitative, and these are features and into the following measurements level. So these measurements level are also called the measurement scale. So nominal levels like brand names, countries, colors. Ordinal levels like a letter grades scales from FN to 8, military rank, level of statistician. Interval levels like years in a calendars, temperature measurements. यानी कि data that can be ordered in a distance between them is observably meaningful and nature to the O value and where the scale links. Like the 0 degree Celsius is a 32 degree of Fahrenheit. This consists the distance between the each degree. Every 1 extra degree in Celsius, so there is a 1.8 extra Fahrenheit. So but they do not agree on where 0 degree is. Ratio level you can see here like money, age and time. So data can be ordered and there is the considered the meaningful data between them. So these are the basic structures, and like means we will discuss like a descriptive statistics. So where is the center of the data like a locations. Second, how much does the data vary, and what is the shape of the data. So the variations of the data like variations of the data is how spread out the data are around the centers. Statistics like standard deviations range and quartiles are measured the variations. Shape of the data, the shape of the data can refer to the how the data is bunched up on either sides of the center. Statistics like the skew describe if the right or left side of the center is bigger skew and is one types of shape parameters. So let's see just a statistical some data you can see here like so some statistics you can see pie charts for the qualitative, histograms is quantitative data, scatter plot is the bivariate data. So I hope, wait 1 minute, so open this notebook. And you can see here the, the so 1 minute, just algorithms, and you could see like a Google stock price forecasting. So yeah, this is the data I have already collected, and we can see here this is the algorithms we can import, like a Parlage as a PD, import NumPy as a NP, and import Yahoo Finance as a YF. Yahoo Finance data has been downloaded, look here, and Matplot. So I am collecting a data like a closing price, and we can see the my closing price is how it is a plotted. So we can see this is the volume and price. Yeah, let's see here, this is the described like a mean we have gotten this data, standard deviations we have gotten easily, minimum value 25 percentile to 50 percentile and 75 percentile and maximum. So we can easily see, and we can easily plot all these data like this. So numerical value you can easily plot this. So box plot like a show the quantile. Similarly, we can also plot like a frequency tables. Okay, so look here, this is the continuous data, like you can convert into the like a continuous data. So frequency means the number of the times value appears in a data. A table can quickly can show the data have a many different value, and it is the easy to the intervals value and present this one. So we can convert into the continuous, look like this one, the relative frequency has been given, the percentile. So cumulative frequency we can get here from the frequency, and we can also set like a histograms. Another is the bin width, bar graph, sets, average, mean, median, mode, just a variations, range, quantile, percentile, interquartile. These are the theoretical parts. So I will try in the future to discuss everyone and how to use in algorithm. Sets like a statical interference, stats normal distributions, standard normal distributions, stat students t distributions, stat estimations, stat populations mean estimations, hypothesis testings, populations, hypothesis testing, population testing mean, and after that just z table, t table, stat hypothesis testings, proportions, stats hypothesis testings, proportions to tell, and stats hypothesis testing mean, stat hypothesis testing mean to tell. Okay, so one is the left tail and another is the mean. So I will try to discuss one by one. So I hope it will be helpful for everyone. So thank you very much.